And the next session is called querying, and the first speaker in this session is Thomas Kerboul, and with the talk Enhancing Authority Files Through SPARQL Federated Queries. Okay, hello again. So now we can actually start the session on querying. So I'm Osmo Suominen from the National Library of Finland and will be moderating this session. So the first speaker is Thomas Kerboul, and the talk will be about enhancing authority files through SPARQL federated queries. So please, Thomas.
Thank you. Show my screen. Can you see it all right?
Yes.
Okay, so thank you, everyone. Welcome to this session. My name is Thomas Kerboul. I'm a metadata librarian at the Bibliothèque de Genève here in Geneva in Switzerland. And today we will be speaking about enhancing authority files through SPARQL federated queries, which is a bit part of what I've been doing. And so the goal of this presentation is really a practical one, and to show how can one librarian in a not so big institution already take advantage of the semantic web. The screen is not going. What is not going? Here it is. For the plan of the talk today, we will start with a few introduction and key concepts. Then I will jump on the main part for the recipe for a good federated query. Then one query example, then thought about the correcting process behind, and then some conclusion. So before starting, I will be using several piece of triple during the presentation. So here you will find all the prefixes to have a bit more space on my slide. So introduction. A few words on the Bibliothèque de Genève. It is part of a network of several other libraries, scientific and heritage ones. Sorry. And together they are part of the Swiss library system platform since its inception in 2020. SLSP is a network of more than 500 libraries, mainly university and heritage institutions. And inside SLSP, all French-speaking libraries use IdRef for authority control, while previously, before SLSP, they were using Kerboul. So it's a bit of a new authority control, to speak, if I can speak like this. And so what is IdRef? IdRef stands for Identifiant et référentiel pour l'enseignement supérieur et la recherche. It was launched in 2010 to serve as a central authority repository for the French SUDOC catalog, for the library catalog of the French university. And now it is used as well in Switzerland and also in Belgium. IdRef uses Unimark as a base recording format. And from this Unimark record, it then exports in RDF, for which it uses a combination of vocabularies, including bio, FOF, old schools, Vivo, etc., a few other as well. And so since 2018, there exists a SPARQL endpoint that we will take advantage of in the next part of the presentation. So here is an example of an IdRef record. I see it's a bit cut on the left side, but I hope on the stream it will be good. So at the top part, we have an identifier and the URI. Then the type of the record. Here we'll be speaking mainly today for person, but there also exists a handful of other types. We have then the heading, alternative access points, structured biographical information. I think on the live streams that not everything is showing. So just to be quick about it, IdRef is quite bare-bone in terms of structured biographical information. Here you have all of them. So in the order, the language of the author, its country, here Swiss, birth date, death date, and gender, and this is mainly old. Then we have some unstructured biographical information, external identifier, and then sources. So this was IdRef, and now I'm moving to a federated query. What are they? Federated query allows us to merge data that is distributed across the web. And to do so, we invoke a portion of a SPARQL query against a remote SPARQL endpoint. So this comes from the official documentation. And what this means is that if you want to do a SPARQL federated query, you really need to specify which value, which triple inside the query, which triple will be queried against which endpoint. So you cannot just put every endpoint in the query and hope that it works. You really need to be specific. And at least one common value needs to be used as a bridge between the two endpoints. Otherwise, you will not be able to execute the query. And what are we doing? Why are we doing this exactly? It's because we want to do some data round tripping, which is a reciprocal syncing of data between two or more databases. So by doing this federated query, we will be able to catch errors and gaps in your authority file that we didn't know existed before by comparing what we have to the remote endpoint and by then correcting either our home repository or the remote repository so that both are actually correct. If the subject of data round tripping interests you, there are two links on Wikidata where you can read more. Now, recipe for a good federated query. We need to choose a remote endpoint. So we have IdRef as a home endpoint. And for the rest of the query, we will be using Wikidata. Why Wikidata? Because everybody can edit it. So I can edit it. And if the mistake happened to be on Wikidata, I can then correct it. And another point is that Wikidata actually stores IdRef identifier, but not the URI. I'll come to that later, as property P269. And as of today, more than 1 million IdRef identifier are currently stored on Wikidata. So it's really massive and it's really useful because Wikidata stores a lot more of structured biographical information than IdRef. So if I want to query, let's say, for people born in Geneva, I can do that in Wikidata, but I cannot do that in IdRef. So it's really something that is really useful in our case. Last thing about Wikidata is that it uses its own ontology. So when we will be doing some mapping for every value that we find in Wikidata, every property, we will need to map it to another ontology that is used in IdRef. So we have the home endpoint, we have the remote endpoint, but now we need to find some common ground between the two. And we will use IdRef URIs as bridge between IdRef and Wikidata. As I said, Wikidata doesn't store directly the URI, so we'll need to rebind the value to have the whole URI. So we have the bridge, and what are we going to compare between the two? Because not every value comparison is meaningful. We need to really aim for some, what I call here with big quotes, unique structured data, is that some biographical data that usually happen only once for a person, and that happen in an objective way. So birthdays as either date and places are good. Also, what is a restricted set, which is something that for given property, something that only have a few pre-selected value. So in our case, it will be gender because IdRef only exports gender when it is male and female. So we can only have found these values. And you will understand later on why I want some really restricted set of value. And another possible thing that we can search for identifier, because identifiers usually are unique as well for people in other vocabularies. What I have retained for comparison so far are 15 properties, so 3 biographical ones, gender, birthday, death date, and 12 identifiers that are commonly found on Wikidata and IdRef, some of them French and Swiss, and some more international. So now that we have the home endpoint, remote endpoint, we know what we want. We need to map ontologies. In our case, it was mostly a manual process. One of the reviewers for this talk asked whether we used Wikidata property P1628 that records equivalence between Wikidata property and the semantic web or the semantic web property. We did not, because at the time I didn't know it existed. But digging a bit later on, I have found that in some cases, the relationship between what is used in Wikidata and what is used in IdRef isn't exactly one-to-one. For example, birth date is Wikidata P569, but IdRef nests a bio date within a bio birth within a bio event. So I'm not sure exactly how would that be modeled in Wikidata. And also in IdRef, most external identifier URI, but not all of them, are stored as all the same as, while Wikidata has a dedicated property and only store the identifier. So we will end up with many Wikidata properties sharing the same property in IdRef. And again, I'm not sure how that will end up, but ultimately I didn't test it all. But unfortunately, mapping ontology is not all that we have to do. It's necessary to also map value to tell the query engine that what occurs to it as different value actually have the same meaning. And why is that? Because as we are mapping different ontology, often their value uses different data type and different formats. One example is for gender. IdRef uses for of gender and either female or male, while Wikidata use property P21 and a wide range of possible value, but if we want to map to female or male, mostly those two value here, and both are URIs. So as a solution, we need to rebind as a set to the value used by the other, so the software understands that they are actually the same. And this is only feasible if such values are few, because if you have 100 of different possible value, it gets quite complicated to construct a query. Then a problem that can also arise is in case of different formats for birth date. So both IdRef and Wikidata use as a standard ISO 8061, but IdRef use bio-event plus bio-birth plus bio-date. Wikidata has only one property. And IdRef can have several different types, so either year month, or XSD date, according to which precision is actually stored in IdRef. For less precise value, IdRef actually changes time. Wikidata, on the other side, always stores the time as date time and records the precision, the lesser precision as 00, and actually store the actual precision in another type. And what you may end up with is this, when IdRef has only 4 digits and Wikidata has a lot more, but both values have actually the same meaning. So here we can have a look at a small query example for querying this date. So we start by querying in Wikidata as a word statement for the date. For the word statement, we extract the rank because Wikidata has this quirk of storing more than one time the date, one of the year and one up to the day. So we need to store to shoot for the best rank. We also query for the actual value, and we query for the time node. And from the time node, we also query the time precision. And then we nest some if within each other to tell, okay, if the time precision is for the year, then I only want the first 4 digits. If it's for the month, then the 7 4-digit, etc., up to the day, and we assume that they are not other value than year, month, and day. Moving now to a bigger query example, you will find more of it here at this link in Wikidata. Yeah, it's a bit okay. So at the top part, you have what we are actually here in the SPARQL endpoint of IdRef. So the first part selected the where is IdRef, and then we move directly to Wikidata, where we ask for an item that works somewhere, and this somewhere is in the canton of Geneva. This item also have an IdRef ID, and then we need to bind the IdRef ID to get the word URI, and then we ask for ORC-ID. And here we are lucky because Wikidata and IdRef actually use the same for ORC-ID. They only store the identifier, so we can leave it like this. and then we rebind it to in case ORCID is missing on the item in Wikidata, we still have one value, which is NA. When we close the Wikidata parentheses, we move on IdRef. I don't know why the boxes are false, but this should be two line up. In IdRef, we ask for the label. We ask for the ORCID. Again, we bind it in case the value is missing. And then we filter to only have at the end rows where the value from Wikidata and the value from IdRef is different. And we end up with this kind of table. In yellow is the most common thing. The identifier is only present in one or the other of the endpoint. In blue is some kind of a false positive where actually this person has two different ORCID. So the value shows twice because for every ORCID it tried to compare it to the other one. So they show both, but actually both are okay. If someone had a solution to get right, that would be really welcome. And in red, it also what can happen is that the value is not the same in both, but it's not like it's missing, like one of the value is maybe false. Moving now to the correcting process. It was mostly so far a manual process. First, because IdRef requires that every bibliographical information be sourced. So for every information that I may find with this federated query, I need to check where the data actually come from. It's not sufficient to say that it came from Wikidata. Identifiers somehow escape this requirement, but then we are left with the question, is this person actually the same person in both identifier, or are we dealing with an homonymy? So double checking is necessary to avoid propagating further errors because library authority files have a tendency to copy each other. So if you introduce one error, you may find it in further authority control files. And conflation, the case that two persons share the same authority file, are especially harmful and may be hard to catch if you are not really looking for it, and maybe even harder to untangle. But correcting may also be a collaborative process, as Wikidata offers a way to engage with other contributors and data providers. It is not uncommon that in my daily work, I need to check with colleagues in Germany and Italy to finalize the completion, because if I have one error in IdRef, it's possible that they may also have these errors. And then is an invitation: if you manage a database with a Wikidata property, consider adding your username there so we can contact you in case we find errors. Again, one reviewer asked if there was any automation possibilities. So sure, you can, in case there is no data or less precise data in your own endpoint, you can replace it with the value found in the remote endpoint, assuming you have a way of mass adding that this value came from this endpoint. But when you actually have different data from both home and remote endpoint, I believe a manual check is necessary to determine which value is actually correct, because you cannot just assume that your home endpoint is correct and the remote endpoint is incorrect, or vice versa. But to be frank, I prefer a slow, narrow, in-depth local approach, a snail approach, where I don't shoot for the more data. My goal is not to work on the whole of IdRef. I'm actually content to work on people related to Geneva. So I really focus on them, and they are not so much. If you are interested, I also linked here a paper, a small blog paper on what is a snail approach. Some conclusion now. GLAM opening the data to the semantic web will have a powerful tool to enhance their own data, but they also have the responsibility to correct their data whenever possible and not to introduce more error, as it's often the case when you massively add data, but the foundation for the addition is not so firm and you end up introducing errors. What was also interesting in all of this is that Wikidata was found to have less mistakes and to be more up-to-date than IdRef. So really, it's a good place to compare your data to, because in most cases, it will be better than what you have. And in the case where it's not better, then you can improve Wikidata and everybody can benefit from it. And from here, I conclude. Thank you for your attention.
Thank you, Thomas. So for the audience, if you have any questions or comments, you can put them in the chat next to the live stream. We have at least one comment. I think this was probably not a question, but it was just a note that I'm reminded of the paper When All Same As Isn't the Same, an analysis of identity in linked data. That's an old paper, but I also remember that one. That was about mismatched identities between systems. And so I guess this is a common occurrence. I wanted to ask about, since you have now experimented a lot with this, using Wikidata as a comparison, how would you say that this differs from the sort of traditional work that people managing authoritative files are used to? Because I suppose in their work, they will also be sort of comparing and contrasting against external data sources. So how is this different when you work with SPARQL and Wikidata compared to the traditional ways?
Well, I think that the main difference is that when there is a mistake in Wikidata, I can also correct it. While when I creating my record in IdRef, if I base myself, let's say, on GND or the Library of Congress, and there is a mistake, I cannot correct it. So they leave with a mistake, and the only way that I could have to correct it is also is to write them a mail to say, okay, you have here an error. But in most cases, it's actually quite sometimes complicated to find the email for the contact form. And for example, the BNF, the Bibliothèque Nationale de France, actually scrapped the whole email thing. So now you cannot tell them that there is a mistake. So I think this is the main point of using Wikidata. Also because up to recently, in SPARQL at least, not every big library has a SPARQL endpoint. Bibliothèque Nationale de France has it. The GND now has it since a few weeks, so this is great. But apart of that, I think the Spain national one has it, and I know of no other so far.
Right. Well, we also have an experimental one in Finland, but it doesn't count. It's a bit old. The data is a bit old. There's a question. Do you actually write these complex SPARQL queries by hand, or are there tools to simplify the matching, for example, with the binding of values?
I do write them by hand with a lot of trial and errors.
Okay. Impressive wizardry. Then another question, how would you describe the perception of Wikidata among others at your institution? Has this changed at all through the work you have been doing?
My position is that most of the time they actually don't know what really is Wikidata about. So they don't have necessarily a bad perception of Wikidata, but they have no perception at all, I would say. So by doing this work, I actually try to make them aware that, okay, this thing exists and we can take advantage of that to actually improve the work, because it's kind of a crowdsourcing thing when you actually don't need to manage the software, manage the return. The data exists, you can take advantage of that. So it's been slowly changing, and I hope that in a few years at least I may have some other colleagues also doing it.
So has it been mostly just you working on this, or have you been able to sort of transfer this skills and processes also to your colleagues, to others working on it? So it has been more of a normal practice. Mostly
myself, sadly, but I also try to design the query so that everybody could use it. You just have to press a button and it's run. And if you need to change something, it's just some parameter and just one thing to remove or to add.
Okay. Thank you very much. This was a very interesting talk. There was a request from the audience that if you can please share your slides on the forum afterwards so that they can take a look.
I will. Thank you, everyone.
Thank you.